Hello everyone. The topic I chose for my final project is to detect the fake news uh, using deep learning. We chose to work on fake news detection because it's a pressing real-world problem with far-reaching consequences. In recent years, we've seen how misinformation can alter public perception, sway elections, and even endanger lives. An example is that during the COVID-19 pandemic, fake articles claiming vaccines were harmful or contained tracking chips spread rapidly. This caused fear and resistance to vaccination, putting public health at risk. Another example is politically driven fake news, such as false claims about election fraud, which can undermine trust in democratic institutions and trigger public unrest. And in the recent times, we could see how fake news manipulated the stock market, uh, which indeed made people to buy and sell stocks due to the panic caused by the fake news. The challenge with fake news is that it often looks real. It uses a professional tone, credible sources, and emotionally persuasive language. Manual checking every piece of content is nearly impossible given how fast it spreads. That's where deep learning comes in. Our goal was to build a system that could help platforms, journalists, or even casual users automatically flag questionable content just by analyzing the text itself. No need for external fact checking initially. If successful, our project could contribute to early detection systems, reduce the spread of viral misinformation, and support fact checkers on moderators by filtering large volumes of content more efficiently. The dataset we chose was two CSV files having uh, the true news articles and another CSV files having the fake articles. So we chose this dataset because it directly addresses the problem we wanted to solve, distinguishing fake news from real news based on the content itself. This data includes over 45,000 news articles labeled as either fake or real. These come from actual media outlets and include political, economic, and world news stories. The dataset had all kinds of news across. What makes this dataset especially valuable is that it's text only. That means we can apply NLP and deep learning techniques directly to this content. Since the project goal is to explore whether we can detect fake news, based purely on language patterns, this dataset is a perfect match. It gives us the raw material needed to train and evaluate our models effectively. To understand how fake and real news differ structurally, we analyze the word count of articles in both categories. As you can see in this box plot, fake news tend to have more variability in length, with some articles going well beyond the typical range. On average, fake news articles are slightly longer than real ones, about 423 words versus 386. The difference isn't massive, but it tells us something interesting. Fake news often uses more elaborate or verbose language. We also notice that some fake articles are extremely long, going over 8,000 words. This kind of outlier suggests some are initially padded with excessive text to appear credible. This is a sample of the dataset which we use. This is from the true CSV file. So this contains all the true articles. From this, you can see the text, the news text isn't that long. So it just conveys that the news is very precise and goes to the point which the news is trying to convey to the users. After cleaning and tokenizing the data, we ran some initial exploratory analysis, for instance, looking at word count and content complexity. This helped us understand how fake news might differ structurally from real news. To tackle the problem of fake news detection, we use different methodologies and approaches. We began by developing a baseline using a simple feed-forward neural network trained on bag of words representations of the text. While this gave us a starting point, it didn't capture the structure or meaning of the language, something that's especially important when trying to distinguish fake news from real news. Since both use convincing and professional language, an ordinary person can't distinguish between a fake and a real news. We then moved to more advanced models like recurrent neural networks, which are better suited for text data because they process information sequentially. This allowed us to capture how words relate to each other in context. For example, how exaggeration, emotional tone, or repetition might be used in fake news narratives. To streamline development and make experimentation more efficient, we use PyTorch Lightning. This framework allowed us to separate the model logic from the training process and run multiple experiments cleanly. We also use TensorBoard for tracking model performance, monitoring loss, and accuracy in real time during training and validation phases. And finally, we experimented with different optimizers like Adam, SGD, and RMS prop to understand their impact on training dynamics and performance. Adam gave us the best results with faster convergence and stable accuracy. This iteration helped us move from a simple baseline to a more robust, context aware architecture that's better equipped to detect subtle cues and fake news. Each step in our methodology brought tangible improvements to our project. The baseline FFNN, that is Feedforward Neural Network, gave us a quick benchmark, but as expected, it plateaued early and struggled with generalizing well, especially on nuanced text. Once we switched to the RNN, recurrent neural network, we saw a noticeable increase in performance, particularly in how well the model distinguished fake news that used emotionally loaded or authoritative language. The RNN's ability to capture word order and semantic flow allowed it to pick up on patterns that the FNN completely missed, when that's the whole purpose of using RNN than FNN. And then, using PyTorch Lightning significantly improved our workflow. We could iterate faster, test multiple models easily, and keep our code clean. The integration with TensorBoard also helped us fine-tune hyperparameters and catch issues like overfitting early in the process. Finally, our optimizer experiments validated that Adam was the best choice for our dataset. It converts faster and delivered more stable results across e- each epoch compared to SGD or RMS prop. Overall, the transition to deeper sequence-aware models combined with a clean training pipeline allowed us to improve both accuracy and reliability in detecting fake news, showing that deep learning, when done thoughtfully, can be an effective solution to this real-world problem. These are the final results and the key observation we got after running all these models and after going through all the TensorBoard logs which we displayed uh, using the models we ran. So we began by comparing a feed-forward neural network and recurrent neural network on the fake news dataset. The results were surprising. Our FNN model reached nearly 99.5% test accuracy, while the RNN struggled, covering around 45%. Even though RNNs are usually better for sequence data like text, in this case, the FNN outperformed it dramatically. This suggests that the key difference between fake and real news may be more about vocabulary and word choice than word order or sequence, something FNN's bag of words approach captures well. With that's when the bag of words approach uh, showed its value and performed much better than RNN. Here, we are showing some of the training logs from TensorBoard comparing performance across models and optimizers. I can't show all the TensorBoard logs which I displayed over there, so I just took one screenshot. I'm gonna explain about this and how this performed and how this was helpful to our project. This plot shows how training progressed over time in terms of validation accuracy. The gray line represents our fake news detection model using a feed-forward neural network, where the blue line is from a CNN model used on a separate image classification task. These visual logs helped us make decisions throughout our project, from choosing the right architecture to picking the most stable optimizers. They were also crucial for diagnosing when a model was underperforming or at risk of overfitting. The final result we got after doing all this performance and after all running models and everything, we used TensorBoard to visualize our training process. With FNN, we saw quick convergence and high stability. The RN, however, had noisy loss curves and didn't improve meaningfully. This suggests that either the RNN's configuration needs tuning or that this task is simply not benefiting from sequence modeling. While the FNN's performance is impressive, we do plan to further verify whether this result reflects genuine learning or potential data leakage or bias. If I were to continue working on this over the summer, I'd like to turn this from just a research project, just like a research paper. I want to turn it into more a real world tool where people can use it frequently and it'll be very user friendly that people can, they itself can use this tool to detect whether news is real or fake. So Initially, my plan is to develop a simple web app or like a Chrome extension that lets user paste in a news article or visit a web page and get a real-time prediction of whether the content is likely false or real. So I mean, right now Instagram is widely used by all the users. So maybe if I were to develop a web application, I would develop a third-party web application where they could post the Instagram post over there in the web application, or we could integrate this third-party application to Instagram, and we could show a little pop-up or like a notification each time they see a post, whether is it a real or a fake. Because right now in this AI world we are living in, we can't detect, a human being can't detect whether a news is fake or real just by observing it. Because using AI, it's very accurate and they can provide very supporting datas and everything, which makes us believe that okay, this is a real news and people will easily believe it. And I think this web application or Chrome extension will be very useful for the users, and they can easily identify between the real and fake ones. So, and to execute this web application or Chrome extension, I'd like to integrate the trained model into the app and focus on making it lightweight and responsive. Possibly using tools like TensorFlow.js or ONNX. Over time, I'd like to add a feedback feature where users can mark whether prediction was correct. This could help improve the model and detect new forms of misinformation. Because we're not sure whether the model will be right all the time because it's not 100% accurate and it's not 100% correct. So sometimes the news may be real, and to the users it'll show it's fake. And maybe to the users they'll know that's a real news because they observed it somewhere else or they saw it live. So maybe we can get the feedback from the users whether this news is real or fake and whether our model predicted it wrong. So maybe getting this feedback will be very useful to further train our model to make it more accurate and to make it sure that these kind of errors doesn't happen later in the future. And I'm also interested in experimenting with transformer-based models like BERT, which could potentially give better performance by understanding deeper language context. So yeah, if I were to continue, I would do all these things and all the cases which I've told you and make it a user-friendly web application so that user can usually use this to detect fake and true news, and so that no misinformation is being spread and people don't panic over a fake news. And hopefully, if I have time, I'm definitely going to pursue this since I'm convinced with my model's results and I think I can improve it and I could provide an application to the users where it could benefit them. So, thank you so much for letting me present this project to you, and hopefully, I can develop it to a more application based so that users can use it. Thank you so much.